Data Representation, Lesson 4, Images. Contents: recap on binary addition, recap on how characters are stored, how images are stored, and the difference between bitmap and vector images. Binary recap. Just a recap to remember that binary numbers are the numbers that computers handle, and they're represented using the symbols 0 and 1. The position of the 0 or the 1 indicates how much that value is worth. In this example, we've got the binary number 1101. If we write the place values above these positions, we get 1, 2, 4, and 8. So all we need to do is add up each column that has a 1 under it. So we get 8 plus 4 plus 1 equals 13. So the binary value 1101 in denary or decimal is the number 13. To quickly recap adding binary numbers, the rules are largely similar to adding denary or decimal numbers. Write both binary numbers one above the other, make sure the columns line up, and then simply apply the rules of binary addition. In this example, 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 0 is 1, and 0 plus 1 is 1. You can check your arithmetic by converting these binary numbers back to their denary equivalents. In this example, it's 4 plus 9 is 13. The only thing you do need to remember is that in binary, a 1 plus 1 is not 2, since you can't write 2 down. A 1 plus 1 in binary is 0, carry 1 into the next column. Recap on how computers store characters. We need to remember that in order for the computer to store something, it needs to store it in binary. To store it in binary, it needs to first convert it into a number. So in this example, we need to give each character a unique number. Upper and lower case have different numbers, and in this case, capital A is given the value 65. This example here represents the ASCII coding system, which has a maximum of 256 different character codes, or a character set of 256 different characters. An alternative to ASCII is Unicode, which uses 16 bits, which gives just in excess of 65,000 different unique codes. How are images stored? An image is basically made up of a grid of pixels, pixel elements, and each pixel is given a number representing its colour. This number is then converted into binary. As we can see here with the picture of Mario, Mario is made up of those grid of pixels. Each pixel has a colour. Each colour will be given a unique number, and then that number will be converted into binary. Two key factors can affect the quality and the file size of an image. The first is resolution. The resolution of the image is the number of pixels wide by the number of pixels tall. In effect, the resolution is the total number of pixels that make up the image. The higher the resolution, the more detail there will be in the image. However, since you are storing more pixels, you need more disk space or storage space. So there will be an increase in file size as you increase the resolution. The other factor that affects the quality of the image is the color depth. The color depth is the number of bits used for each pixel. If we simply used 1 bit per pixel, we could represent two colors, a 0 or a 1, black for instance, or white. If we use 8 bits per pixel, then we would have 256 different colors, and if we use 16 bits per pixel, we could represent a total just in excess of 65,000 colors. But again, increasing the color depth of an image would also increase its file size. Bitmap images pros and cons. The main advantage of a bitmap image is it's best suitable for storing photographic images that have some sense of realism. They're fairly easy to process since you're processing individual pixels, and this requires limited maths. And there are some very common file formats that can be used for bitmap images: JPEG, BMP, GIF, PNG, and so on. However, there's some cons, disadvantages to bitmap images. If you enlarge the image above its original size, it will become pixelated. File sizes can be large, and it's not very easy to edit individual objects within the bitmap image. Pause for thought. So before you move forward in this presentation and this video, make sure that you can explain to yourself how computers store images. Can you explain the terms resolution and color depth to yourself? And can you give some advantages and disadvantages of bitmap images? If you can't, go back in the video, in the presentation, review the material again. It's really important that you understand these concepts before you move forward. An alternative to the bitmap way of representing images is to use what's called object or vector-based graphics. Instead of storing individual pixels for the image, an object or vector-based graphic image is made up of a series of independent shapes or objects. Each of these shapes has XY coordinates stored about them, just like you might an image on a graph, and there's also individual data stored about the image to do with its line colour, its fill colour, etc. So, what are the advantages and disadvantages of object and vector-based graphics? An advantage is that vector-based graphics or object graphics are suitable for diagrams, charts, or even cartoons or illustrations. In an object vector-based graphic image, you can easily edit or modify individual elements in that image. You can pick up shapes, move them, enlarge them, change their background colour. Because you're only storing XY coordinates of the image and some additional data such as fill colour, line colour and so on, they require less storage space. And because the image is recalculated each time you reshape the objects, they scale and enlarge without any pixelation or distortion. However, there are some disadvantages. It would be unrealistic to use object or vector-based graphics to represent photorealistic images. They may require more processing power than bitmap images, as you need to recalculate the coordinates of every object in the image when you resize it. And the file formats aren't that common, including SVG, EPS, and the PDF file format. In addition to representing the data for the image, files may also contain what is called metadata, or data about data. In an image, this metadata might include information such as the date the file was created, the date the file was last modified or changed, the author of the file, the resolution of the image, its color depth, and even for photos taken with a digital camera, it might even include the GPS location of where the image was actually taken. Pause for thought. So again, before you move forward, make sure that you can explain to yourself the difference between bitmap images and vector-based images. Can you give some of the advantages and disadvantages of each? And can you explain what metadata is and give some examples of such data? If you're unsure, again, revisit the slides in this presentation, go through the content again, and make sure you understand it before you continue. So that's the end of this presentation on how computers store images, both bitmap images using individual pixels and vector or object-based images which store the individual XY coordinates of each shape that makes up the image. Please go back and rewatch anything if you struggled. Try and explain some of the terms to yourself or maybe a friend or a family member. Write them down, for instance, even diagram them. And more importantly, if you still don't understand it, don't give up, go back, review the material, maybe even search out some more videos on YouTube that might help explain it.